In this video, I want to talk about how to write an equation for the tangent line of the graph of a function at a given x value. First, let's give a nice definition to what a tangent line is. Well, Leibniz defined a tangent line as a line through a pair of infinitely close points on the curve. In general, a tangent line is a line that just touches a curve at a single point, and it matches the curve's instantaneous rate of change, or slope, at that point. And the point at which this occurs is called the point of tangency. So let's look at a quick picture of what this might look like. For the most part, it's easiest to write these equations in point-slope form because you will only need an x value, its accompanying y value, and a slope. So let's go ahead and remind ourselves point-slope form is y minus y1, which is the y value, equals m, which is the slope, times the quantity x minus the x value. Well, let's go ahead and look at two examples and see what this is going to look like and how maybe we can even generalize this more to make it fit tangent line equations even better. So we have the function f of x equals 3x cubed minus 8x plus 2. And I would like to write an equation of the tangent line to the graph of this function at x equals negative 1. Okay? Well, I have an x value, that's negative 1, so I know my x value will go right here. But I don't know the y value and I don't know the slope, so I'm going to have to get those two pieces of information. So my ordered pair is negative 1 something, and my slope is, well, something, I'm not sure yet. So let's go ahead and see how we can go about getting these pieces of information. Well, if negative 1 is my x value of an ordered pair that's on this function here, I need to plug in negative 1 into the function to get that accompanying y value. So that y1, or the accompanying y value, will be f at negative 1. Okay, well, let's go ahead and drop negative 1 into my function. And it looks like I'll have, well, negative 1 cubed is negative 1, so 3 times negative 1 is negative 3. Negative 8 times negative 1 is positive 8, and then plus 2, and that equals 7. So I can go ahead and finish up this ordered pair by saying 7. So negative 1, 7. Well, how about the slope? We don't have the slope yet. Well, how can I use this function to find that instantaneous rate of change, or that slope at the x value, negative 1? Well, I'll need to find the derivative of that function and then plug negative 1 into it. So the derivative, 3 times 3 is 9, and then we'll have x squared minus 8. So by plugging negative 1 into my derivative, I have 9 times negative 1 squared minus 8. So 9 minus 8 is 1. So the slope actually is just 1. Well, now I have a slope and I have an ordered pair. Let's go ahead and plug it into my general point-slope form and kind of get an equation here. So y minus the y value, so y minus the y value is y minus 7 equals the slope, which is 1, times the quantity x minus the x value. So x minus negative 1. And we can kind of simplify this a little. We could say y minus 7 equals 1 times x plus 1. And that would be written in point-slope form. We could also transition this pretty easily to slope-intercept form if you like. We could basically just add 7 to both sides and we'll end up with y equals x plus 8. That would be another form of that same line. So let's go ahead and use kind of the process, what we just did, to rewrite this point-slope form equation in a way that better suits our needs of writing tangent line equations. So y minus the y value equals m, which is our slope, times the quantity x minus the x value. So for our intents and purposes, we're going to say our x value is going to be c. Okay, that's used a lot. So y minus the y value. What was the y value? How did we get that? Well, we plugged the x value into our original function. So c into our original function. So y minus f of c. Okay, well that equals the slope. And how do we find the slope? Well, we put that x value into the derivative. So c goes into the derivative. And then x minus that x value, well, that x value is c. So right here we have a really great equation. Y minus f of c equals f prime of c times the quantity x minus c. And that's going to be a general point-slope form equation that we can use to write the equation of tangent lines. So that was what the graph of that looks like. So let's go ahead and do a second example. I have f of x equals x times the ln of x. And I want to write an equation of the tangent line to the graph of this function at x equals 1/4. Okay, so we just said we need to plug 1/4 into our function, and then we need to plug 1/4 into the derivative. And then we can write this equation. All right, so let's find f at 1/4. So that's going to be 1/4 times the ln of 1/4. So you could write it this way, or I know that 4 is kind of a power of 2, and I know the properties of logs, I could kind of rewrite this a little bit. So I could have 1/4 times, and this would be ln of 2 to the negative 2. And then I could bring that negative 2 out front, which would ultimately make it negative 1/2 times the ln of 2. And that would kind of make it a little concise term there. Okay, so f at 1/4 is negative 1/2 times the ln of 2. So now I need to find the derivative so I can, plug 1/4 into the derivative. So f prime of x equals, looks like we'll need the product rule here, so x times ln of x. So it's the derivative of the first times the second plus the first times the derivative of the second. And then let's go ahead and kind of simplify this. And the x's cancel, so I have a 1. So it looks like the ln of x plus 1. So to find that slope, I'll need to find f prime at 1/4. So it ends up being the ln of 1/4 plus 1. And again, if you wanted to, you could rewrite this as the ln of 2 to the negative 2 plus 1, or negative 2 times the ln of 2 plus 1. And if you didn't like it leading with a negative, you could bring this out and say 1 minus 2 times the ln of 2. And that will be my slope. Okay, so now I have my two pieces of information, my slope with my associated y value that goes with this x value. So let's go ahead and write this tangent line equation. Y minus f of c. So y minus the y value. So y minus, and that y value was negative 1/2 ln of 2. So negative 1/2 ln of 2 equals, equals the slope here. And our slope was 1 minus 2 times the ln of 2 times x minus, and then x minus my x value, so 1/4. Okay, sometimes these things are going to come out really nicely, honestly, and sometimes these things kind of can be ugly, and that's okay. Let's go ahead and simplify this a little. So we have minus and negative, so swoosh, swoosh. Y plus 1/2 the ln of 2 equals 1 minus twice the ln of 2, and then x minus 1/4. So here is an equation of the tangent line to the graph of our function at x equaled 1/4. So here's what a graph of that will look like.